Hi students, welcome back. Today what are we going to take? 25th February Shift 1 physics paper we are going to analyze and solve it through. So students, if you would have given this paper 25th February Shift 1 paper physics, and are you going to give the coming sessions examinations, as far as physics is concerned, the papers are not at all so difficult. And one thing is, this paper when comparison to 24th Shift 1 and Shift 2, a kind of bit lengthy we can say, and some questions are tricky, so not more than that. So 10 questions to 12 questions will be very easy, 5 to 6 questions are moderate, few questions are lengthy. So let us go to the journey of this paper. So first question is time period of simple pendulum at a planet. This is can be considered, we can consider this as easy question. Time period of a simple pendulum at a planet is 2 seconds. Length of simple pendulum is 2 meters. Find the value of G at that planet. We know what is the G, what is the time period formula? Time period formula is 2 pi root over L by G effective. So if G effective is changing, so then the time period of the pendulum will change. Suppose we have seen the kind of cases, if the ball is kept in a liquid of this sort which is of density rho L, we have seen in our lectures how the time period will vary when the effective gravity on this ball is changing. Also when the simple pendulum is kept in a lift, we can see when the lift is accelerating upwards, then time period will be 2 pi root over L by G plus A. When it is accelerating downwards, the time period will be 2 pi root or L by G minus A. If it is accelerating, if it is in a car and accelerating in the forward direction, there will be a pseudo force on it. The time period will be root over L by root over G square plus A square, which is effective acceleration. So these are the cases you might have studied while practicing for examinations in a short revisions. So connecting to these cases, if you would have known this formula 2 pi root over L by G effective, so what is the effective G in the planet? Here students, so G planet here, G effective will be the acceleration due to gravity on the particular planet students. So time period is equal to 2 pi root over L by G planet. The question what is asked here, L is given as 2 meters. To find the value of G, we need to find out value of G. Time period is given as 2 seconds. So now 2 is equal to 2 pi root over L by G planet. If you square on both sides, if you want to make G as a subject here, so 4 is equal to 4 pi square L by G. So 4 is equal to 4 pi square L by G. So G is equal to pi square into L. L is how much here students? 2 meters students here. So the answer will be 2 pi square is the answer. This is easy and formula based questions, which is 2 pi root over L by G effective. If you are able to know this formula, you can solve this question easily students. Then let us go to the next question students. This question students, before this question paper is being released, I have taken 24th January Shift 2 paper. You can go and watch that paper at the 18th minute. I have solved similar kind of question in another topic and on center of mass, and explained questions might be asked in this way. If you can go through that question there, you will be able to understand. What did I say? I told 5 to 6 models on the same concept of removal of part. In rotational motion you can expect question, in electrostatics you can expect question, in gravitation you can expect question, rotational motion in moment on moment of inertia. This question you see, a sphere of mass m has gravitational field at point P is G1. The same question I explained, making gravitational field intensity I explained. So now volume cavity of radius r is removed as shown. Now new gravitational field is G2. That means initially there is a sphere, the gravitational field intensity due to the sphere at this point will be some G1, then some part of the sphere is removed, a volume cavity of this much part is removed, then the gravitational field intensity is P2, that means due to the remaining part. So now what is the ratio of G1 by G2? So what did I ask you students in the previous class? Just the previous shift I solved similar question to center of mass. There I explained questions might be asked on this removal kind of questions from gravitation also, from electrostatics also. Similarly, electric field intensity at this point due to the entire sphere, after that removal of so and so sphere cavity from the sphere, what is electric field intensity at that point. And also rotational motion I explained about, suppose this is a sphere, the moment of inertia of the sphere about this axis is suppose I1. We don't need to solve here, just I am trying to explain what kind of models that might come. So then suppose so and so r/2 radius sphere is removed from this whole sphere of capital R radius. So then what is the moment of inertia of the remaining sphere with cavity? How to solve this question, students? Try to find the moment of inertia of the entire sphere. You take it as I1, equate it to I1. Try to find the moment of inertia of only this sphere, that removed part sphere, about the same axis, and try to subtract them. You will get moment of inertia of this remaining part of the sphere about the given axis. So this is a question similar to this question in rotational motion. Gravitation, this is the question. Electrostatics also they might ask you about electric field intensity. These are the variable questions that I have taken in just previous shift 1 by analyzing the what kind of questions that might be appearing with this model. If you are new to this, if you haven't listened to this, you try to go and practice this kind of models, students. So then now we'll solve this question by using the same concept. This is on this model nearly 10 times, more than 10 times in previous years questions have appeared from different topics using the same concept, students. That is why I am stressing it more and more here. So now a sphere of mass m has gravitational field at point P is G1. So try to write gravitational field due to entire sphere at this point. What will be the gravitational field intensity? So that is I1 is equal to, I am taking it as to the entire mass, G m by r square, small r square, that is the distance from the center to that point. If it is an external point, so that is 3r whole square. The answer will be G m by 9r square. Similarly, what did I tell you? Try to find out what is gravitational field intensity due to this sphere removed part. Why? Field intensity due to this part, first part, field intensity due to second part is equal to field intensity due to entire this sphere or this sphere on this point. So 1 plus 2 is equal to total gravitational field intensity, that is I1. So if you want due to first sphere here, that means remaining portion, you will get total minus 2. If you are able to do, you will get this answer in a vector form. So what we will do, we will try to find out intensity due to this bigger sphere, intensity due to this small sphere, and subtract them, intensity due to the entire sphere, and subtract this small sphere intensity due to this small sphere. You will be able to get the gravitational field intensity due to the remaining part of the sphere. I wrote the entire sphere intensity and intensity due to the entire sphere on this P point, that is Gm by 9r square. Similarly, I will try to write this 2, that is this one I will take it as I total, I will take it as I2 here, I2 G into what is the mass of this sphere, students. So we know it is uniform, we can consider, because he has not mentioned anything, we can consider this as a uniform sphere. If it is uniform sphere, density will be same. So then mass will be, mass of this removed sphere will be the density into volume. So if you take density is constant, then the mass will be proportional to volume here. So for mass is for entire volume of the sphere, that is 4 by 3 pi r cube, 4 by 3 pi r cube. The mass is total mass. So what will be the mass for 4 by 3 pi into r by 2 whole cube. This will be how much? 4 by 3 pi r cube divided by 8, 2 cube 8. So this mass will be how much? M by 8. So substituting those values, so g m dash by, I'll write it as, what is the distance from this center to this point, students? 3r minus r by 2. 5r by 2 is the distance. 3r from here to here minus this r by 2 is the distance from center to the point, that is 6r minus r by 2, that is 5r by 2. So this will be g m dash by, m dash is already m by 8, we can substitute in the later calculations. 5r by 2 whole square, that will be 4 g m dash by 25 r square. So m dash is how much, students? M by 8. Substituting m by 8 here, 4 goes it by 2 times, the answer will be g m by 50 r square. So we got I2. So if we subtract I total, intensity due to total sphere, minus intensity due to the second sphere which is removed part, so we will be able to get due to first sphere. So this is, can also be considered as G1. So then G1 by that remaining first part, G will be the ratio of the required answer. So if you subtract this I total minus I2, I will try to solve it here. I total is what? Gm by 9r square minus removed part will be how much, students? Here removed part will be Gm by 50 r square. So if you try to make it 50 into 9 as LCM, r square here, so 50 minus 9, that will be 41 Gm by 50 into 9 r square. This is the remaining part, that is I1 intensity due to this remaining portion, because what did I do? Entire sphere intensity at this point minus removed part intensity at this point, I got the remaining part of intensity, that is I1. So now what I need to do? I total by I1. So I will do it here, students. I total is Gm by 9r square by removed part, remaining part will be 41 Gm by 50 into 9r square. 9r square gets cancelled, students. So Gm gets cancelled, students. So then this 50 goes to the numerator, that will be 50 by 41 will be the answer, students. So the option here should be 50 by 41. This might be looking a little bit lengthy, students, but while you practice this similar kind of question, this becomes a cakewalk to you to solve this kind of questions, students. So let us go. This is a quality problem, one of the most valuable concepts and problems. You can make it very standard model. So let us go to the next question, students. So this question, the previous question has a calculation in it. It's a standard model, repetitive model, but has a calculation in it. But this question is not for every student. I feel that you might have solved this question, students. So what is match of the following dimensions? I'll do it quickly, students, because this question is easy. Kinetic energy dimensions, that is energy dimensions will be, half mv square, you can substitute here. Otherwise energy dimensions also you can apply. That is half mv square dimensions, if you take ml square t power minus 2, students. Momentum is mass into velocity, so then m into l t power minus 1, students. So Planck's constant is equal to E equal to h mu, mu is equal to 1 by t. So energy into time will be Planck's constant dimension, students. Number of times Planck's constant dimensions are asked in examinations as well. So energy into time, that is ml square t power minus 2 into time will be ml square t power minus 1, students. Electric potential is nothing but energy per unit charge, that is ml square t power minus 2 divided by q is, you can write it as IT, students, IT. So then what will be, I is current, T is time. So ml square t power minus 3 charge, potential energy is ml square t power minus 2 divided by IT, that t power minus 3 we can write into I power minus 1 we can write. So this will be ml square t power minus 3 students. This is a correction that has to be happened. So these are the dimensions analysis that we need to do, correct dimensions. So let us go to the next question, students. In given LR circuit, the previous session itself I have taken a question on inductor, how to treat the inductor and capacitor. So if you would have missed that, you go to the previous shift, that is 24th February, second shift. Before the shift paper has come only, I have explained, because similar kind of concept has come, how to deal with that kind of question. With that kind of question I have explained, students. You can go to that video and can watch it. You can go to that video and watch it, students. So what to treat? In that video I explained, initially when the just switch is closed, when the switch is closed, that means t equal to 0, inductor offers infinite resistance and current, you can remove the inductor and make it a open circuit. Through the inductor current will not flow, because a back EMF will be generated which will be equal to the original potential energy, potential difference between the inductor. That is, inductor will offer infinite resistance and no current will flow at t is equal to 0, just when switch is on. At steady state, you can remove the inductor and make it a short circuited wire. Just you join a wire, both of them, no resistance, and then you can join the wire and you will have current through that inductor. If capacitor is there, there will be difference, matlab reverse, the operation will be difference. At t is equal to 0, capacitors you can treat it as, this is for inductor. At t is equal to 0, inductor is open circuit here. At t is equal to infinite, you can consider this inductor as a simple wire. You remove inductor and try to consider as a simple direct wire connection. And for a capacitor, t equal to 0, you can remove the capacitor and treat it like a normal direct wire connection there. For infinite, that is steady state, at steady state we can consider the capacitor as open circuit. Just the process will be reversed. So now the question is based on inductor. So what we can do, at t equal to 0 and steady state, they ask at t equal to 0, we have to consider inductor as this one. At t is equal to steady state, that at t equal to infinity, so we can remove this inductor and join it with a wire and solve the problem. So now when t equal to 0, we can remove the inductor and this will become an open circuit. It becomes an open circuit. So then what will be the answer here? So I am trying to rearrange the circuit here to make our question easy. That's it, students. So now we can consider, so whatever current that flows here has to come back again to 1 ohm. Whatever the current flows here in 5 ohm again has to come back to 4 ohms, because this wire is an open circuit here. So then we can consider this 4 and 5 are in series, then 5 and 1 are in series. Then what will be the resistance here? So this will be written as 6 ohms. And this will be written as 9 ohms. So now you see, students, this is the potential difference. If this potential, if you consider as 0, you will be EMF, that is E of the battery. So now 6 and 9 are parallel to this battery and they are also in parallel connection between the same points. So then what will be the effective resistance? 6 into 9 by 6 plus 9, that is R1 R2 by R1 plus R2. 6 plus 9 will be 15, students. 3 2s are 3 5s are, answer will be 3 2s are 3 5s are, answer will be 18 by 5. So now what will be the current? I is equal to V is equal to IR, I is equal to potential difference by R. Potential difference is what? EMF of the battery by R effective, R equivalent is 18 by 5. So 5E by 18 will be the value at t is equal to 0. So the options, this cannot be option, this cannot be option, this or this can be the option. But let us solve the next part of the question also, either this or this one. So let's solve the next part of the question. So now in the next part, what we need to say, we need to connect it like a wire. So if I redraw and arrange this, I am removing, just remove here itself, I am removing here and I am connecting it like a wire. So if I connect here, try to use nodal analysis for it so that your problem becomes simple. You can use Kirchhoff's law as well, but it will be lengthy calculation. So if I consider this as 0, students, why you need to consider 0? You can consider it as 5 also, whatever you want, but if you consider it 0, there will be 0 plus E will be the potential at this point. If you consider it is 5, it will be E plus 5 will be the potential. I am considering this potential at V. If this is V, this is, you see here, this wire is directly connected to this wire without any resistance. So whatever the potential that will happen, that will occur at this point, will also be the potential at this point. If this is V, this will also be V, because this is a wire in connection without any resistance. This is V, this will also be, this will also be V, and this will also be V. So if you see here, seeing nodal analysis, this is V and 0 and this is V and 0. So that means 1 and 4 ohm are having the same potential difference. They are between the same potential difference. So what we can say, 1 and 4 we can treat it as parallel. So parallel means 4 into 1 by 4 plus 1, that is 4 by 5 is the effective resistance due to 1 and 4. Then 5 and 5, you see E and V, difference is what? E minus V. This one also EMF minus V. So again 5 and 5 are parallel, they are having the same potential difference. So 5 and 5, if you say 5 into 5 by 5 plus 5, the answer will be 5 by 2. 5 by 2 will be the answer. Now this is effective resistance. Now if I try to redraw the circuit, so this will be 5 by 2. Then for V, they are connected as, this is 4 by 5, and then it is connected here, because 4 by 5 is between this one, V and 0 effectively, but V and E it is 5 by 2. So what we can say, between E and V it is 5 by 2, and between V and 0, if I consider 0 here, this is E here, and V and 0 it will be 4 by 5. So they can be considered in series. If they can be considered in series, same current flows here, whatever current flows here will have to come back and flow in these two resistors. So same current flow here. So we can consider they are to be in series. So if they are in series, what will be the effective resistance? R1 plus R2, that will be 5 by 2 plus 4 by 5. If we consider the LCM here, 25 plus 8, that is 33 by 10. So V is equal to IR, so EMF is equal to I into R, R will be 33 by 10, so then I will be equal to E by 33 by 10, that will be 10 E by 33 will be the answer. So the answer should be this one. So if this is the data that is being given from memory based, so this will be the appropriate answer, and this is the process you need to approach for solving this question. Students, so let us go and solve the next question. So this question, students, is also based on a concept similar to many questions which have been asked from previous years. If you place a battery of 5 volts between X and Y and terminal X is made positive and find the current through cell, diode is made from silicon. Diode is made from silicon. If diode is not made from silicon, or if diode is made from silicon, how to solve this problem? What are the similar questions that have been given and asked in the previous year examinations is, a diode offers in the forward biased, the concept you need to know, an ideal diode in the forward biased offers zero resistance. An ideal diode in the reverse biased infinite resistance. That means if a diode is forward biased, so then ideal diode will allow without any resistance. That means we can remove the diode and just join a wire there. So if in reverse biased the current will not flow at all in the direction in that diode. Suppose if X is taken as positive, Y is negative, so this current, now this D2 is offering infinite resistance and current will not flow to D2, and you can remove this, as we can consider this as open circuit which does not have connection, and solve the problem. Then the answer will be, and in ideal diode this will be D1 will offer zero resistance. That means you just remove it and connect it and connect the 2 points. What will you get, students, from this concept? So this will be 5 and 10 ohms. So 5 by 10 is equal to 1 by 2 amperes will be the answer, students. That is 0.5 amperes to the answer. This is the pattern that number of years question has been asked. But here diode is made from silicon. If it is made from silicon, students, it will have a energy gap of 0.7 volts. It offers a potential difference of 0.7 volts, because you might have studied that silicon diode, so silicon PN diode, so there will be a bandwidth of, here the potential difference between this energy gap will be 0.7 volts per silicon diode, students. So for every diode it will vary. For germanium it will be around 0.3. Suppose if you are giving a positive terminal which is having a voltage which is higher than 0.7, then the bandwidth, then current will flow in the opposite direction and it will pass from here to here. Otherwise, if it does not offer, if the given potential is not higher than 0.7 volts, even in the forward biased, if it is ideal, it should allow. But it is for a real diode of silicon, there will be a band gap here which is forbidden energy here. So there will be a band gap here, so current will not flow easily. So what can we say here, students? So because here we can remove this and keep a battery which is opposite, which is having a potential difference of 0.7. So the net effective potential difference will be how much, students? So 5 minus 0.7 divided by 10. So the answer will be 4.3 by 10, 43 by 10, that will be 4.3 ampere, students. If it is the ideal diode, it offers zero resistance. You can remove it and solve the problem easily and flow the current to that wire. For forward biased, for reverse biased, it will be zero current. But if it is silicon diode and germanium diode, if they mention, there will be a potential difference of 0.7 opposite to the original EMF. So let us go to the next question, students. So this question, silicon diode is used. So here silicon diode is used. This is a solution to it. And now this is a question based in mechanics, students. Just by using speed equations, you will be able to solve this question, students. So a train passes by a pole with uniform acceleration a. Its front end when passes by it has speed u, and its back end when passes by it has speed v. Find speed of the middle part when it passes by the pole. It is a constant acceleration, students, the particle. Then a train, if I take a train of length L, so there is a point here. When the train's front end has approached this pole, what is the velocity of the train? That velocity of the train will be u. When the train end point, when the train has reached this position in this way, I consider it A and B. So what is the velocity of this point, students? It will be v. Then the question is asked, when the train is in this condition, when the train midpoint is passing through the pole, what is the velocity of the, find speed of the middle part when it passes through the pole. Middle part speed is nothing but what? Train speed. At a moment train will have the same speed, entire train speed. So now what is the length traveled by the train when it is going from top end, when it is crossing from top end to bottom end, the length traveled by the train is how much, students? L, students. So what is the displacement of the train? Is L, length of the train. That means if you say when it is traveled a length L, what is the velocity of train has become, students? V. Before the velocity is U, so you know initial velocity and final velocity and the distance traveled by the train, you will be able to write the equation of motion, that is V square minus U square is equal to 2 into A into S. S will be how much, students? L. Similarly, if I want to draw an equation, so initial velocity is U when the train's starting point is at the pole, and when the train's midpoint is at the pole, what is the distance traveled by the train, students? That is L by 2. Then I am considering the velocity of the midpoint of the train to be some P. P square minus U square is again equal to 2A into displacement traveled by the train or distance traveled by the train is L by 2. So these are the two equations. If you can eliminate L from here, so then if you can find out the relation P, what is P here, then you will be able to get the answer, students, here. So now, so this will be AL, students. What is AL here from the here equation? V square minus U square by 2A. So I want to eliminate the other part of it. So P square is equal to U square plus AL. What is AL, students, here? V square minus U square by 2A. What is AL? You see here. What is AL? V square minus U square by 2. What is L is V square minus U square by 2A. What is AL here? V square minus U square by 2. So P is equal to U square plus V square minus U square by 2. If I take the LCM, this is 2U square plus V square minus U square. That is U square plus V square by 2 will be the answer for P square. P is equal to root over U square plus V square by 2 will be the answer, students. So just by using speed equations, you will be able to solve. You might feel it a bit lengthy, but by using speed equation, you will be able to solve the question. So what is the next question, students? So now this is based on screw gauge, students. Screw gauge shows, if you would have known the basic formula for finding out the measurement of the screw gauge, main scale reading plus circular scale reading into LC is a formula for finding out the measurement on screw gauge. But also if there is a correction, if there is a positive error, then negative correction should happen. Positive 0 error, negative correction should happen. If there is a negative 0 error, then it should be, correction should be positive. So let us see here, students. A screw gauge shows 8 divisions on circular scale below, 8 divisions on circular scale below reference line. So below reference line. So reference line 8 divisions on circular scale. So then the error will be positive. 8 divisions on circular scale below reference line. There, that means what? 0, 1, 2, 3, 5, 6, 7. In the circular scale, 0 is below the reading is, students, here. So before circular scale, what are the divisions? 8 divisions. So error will be positive here, students. If this is above, the error will be negative. If error is positive, 0 error is positive, then correction should be negative here, students. So then what is the formula for this, students? Main scale reading is 1 millimeter. So 1 millimeter plus circular scale reading is 72 into what is least count, students? Least count formula you might have studied. Least count is equal to pitch by number of divisions. Pitch is how much, students? For one rotation, what is the distance travelled by the scale is actually the pitch. What is the distance travelled, students, for one rotation? Advanced it by 1 millimeter, students. Advanced it by 1 millimeter. So pitch is 1 millimeter. Pitch is 1 millimeter, students. By number of divisions is 100 divisions, students. So this will be, least count will be 1 by 100, students, here. The main scale division, here the main scale division reading is not given in the question typed here. So the main scale reading is 1 students here. So 1 plus 72 into 1 by 100 minus, so what is the error students? Positive correction should be, so positive error is there, negative correction should happen. How many divisions are matching here students? 8 divisions. So 8 into 1 by 100. So this will be 1 millimeter plus 72 minus 8, that is 64 millimeter students. So the answer will be 0.64 millimeter, that will be 1.64 millimeter. So what is the main formula students? The main scale reading plus circular scale reading into LC is the main formula, but if there is a correction, you need to understand how much correction you need to do. If it is a positive error, you do negative correction. If it is a negative error, you do positive correction students. So by using this formula, you can solve the question here students. So now this question is based on vertical circular motion students. What is this question based on? Vertical circular motion. If you know the previous session I took, there in one shot revision I explained about problems on vertical circular motion on Newton's laws of motion topic. You can go and watch that video. So there we studied, or you might have studied as well, if you know two equations. What are those two equations? One is force equation, other is energy equation. You will be able to solve any problem in vertical circular motion students. How to draw the equations here? So two equations is what? 2e minus mg cos theta. So when the particle has started from this position, this is the theta. So t minus mg cos theta, theta taken from the vertical, t minus mg cos theta is equal to mv p square by l, or r, radius of this so and so circle, or length of this distance between this fixed point and the ball, length, mv square by l is the equation of force, and energy equation is what? mgl into 1 minus cos theta is equal to half mv square minus half mv square. That means gain in potential is equal to loss in kinetic energy. mgl into 1 minus cos theta is equal to half mu square minus half mv square. So if you take the 2 points here, when will be the tension maximum here students? The tension will be maximum at the bottom point and the tension will be minimum at the topmost point. So I will take it as bottom point and topmost point and try to solve the problem here students. So tension at the bottom point minus mg cos theta. What is theta here students at the bottommost point? 0. So t minus mg is equal to m into vp square by l students. So what is the velocity here? I am taking it as u square, mu square by l students. So I need to find out at what? The question is asked, ratio of the maximum to minimum tension is only asked, given. Minimum speed will be at the topmost point student, because there maximum potential energy will be there, so minimum kinetic energy will be there. Minimum kinetic energy is there, that means minimum speed will be the speed of the ball at the topmost point. If you are able to know the topmost point velocity, your answer is solved. So I am trying to use this equation and get the topmost point velocity. So Tb minus mg is equal to mu square by L. Then T topmost point, so minus mg cos theta. What is theta here students? 180. So cos 180 is minus 1. So T plus mg. You can use this equation also, otherwise you draw the free body diagram here. So tension will be downwards away from this ball, because tension will cut it and pull it. The tension will be downwards, mg will also be downwards. So topmost point plus mg is equal to m, that is providing the centripetal force for the ball here to move in a circular motion. Then that will be mv square by l. I am considering the topmost point velocity as v here, otherwise you can say ub v top. So then, so what is the ratio given here students? Bottom to top, because maximum to minimum ratio is 5:1. So what can I solve here? So Tb So TB is equal to mu square by L plus mg. T top is equal to mu square by mv square by L minus mg. So if you take the ratio of both of them, T bottom to T top, it should be 5/1 according to the question here, students. That's equal to mu square by L plus mg by mv square by L minus mg. But one important relation, students, here, u square mgl into 1 minus cos theta, I told mgl into 1 minus cos theta. Otherwise you can write it as ki plus pi here is equal to kf plus pf, conservation of mechanical energy at these 2 points here, students. So mgl into 1 minus cos theta will be 1 minus cos theta is minus 1 here because when it is travelling 180 degrees. So mgl into 2 is equal to half mu square minus half mu square minus half into mv square. This is the gain in potential is equal to loss in kinetic energy, students. So if you want half mv square, you want v square, students, so I want to eliminate u square. So half mv square, half mu square is equal to half mv square plus 2mgl. Half mu square is equal to 2mgl. So substitute this half mv square. So here if I cross multiply and get the equation here, students, so 5 into mv square by L minus 5 mg is equal to mu square by L plus mg, students, here. So 5 mv square by L minus 5 mg is equal to mu square by L plus mg, students. So this will be 6 mg here when this 5 mg goes that side. So here it will be 5 mv square by L minus mu square by L, students, here. So how can we write the relation between both of them? Mu square, half mu square is equal to half mv square plus 2 mgl. So if you send that side, so mu square is equal to mv square plus 4 mgl. So you can substitute instead of mu square, mv square plus 4 mgl, mv square plus 5 mv square by L minus mv square plus 4 mgl, students, here by L. So then this L gets cancelled here, students. So this will be equal to 6 mg here, students. So 5 mv square by L minus mv square by L is 4 mv square by L minus 4 mgl by L, that will be minus 4 mg is equal to 6 mg here, students. So this will go to, if minus 4 mg goes to that side, this will be 10 mg, that will be 4 mv square by L is equal to 10 mg, students. So gets cancelled, 4v square is equal to 10 gl, so v square is equal to 10 gl by 4, it is 2 2s are 2 5s are, so v is equal to root over 5 gl by 2 will be the answer, students. Question might be a bit lengthy, students, but using those two equations, tension equation and energy equation, you will easily get the answer just by being careful while calculating the solution, students. I would have preferred you to solve these lengthy questions at the last attempt of your paper, students, not in your first shot. So this is also a question which is involving calculation, students, but just by basic formula. Lengthy calculation, but the basic formula is, when are the height of, you see, two planets 1 and 2, the question is based on finding out the time period, students, and you need to calculate those time periods. Two planets 1 and 2 of masses 400 kg and 600 kg respectively revolves around Earth. which are at a height of 600 km and 1600 km above the Earth's surface respectively. Find T2 minus T1. What is time period, students? 2 pi r by v or 2 pi by omega. So if you consider this one, 2 pi r1 by v1 is what? Orbital velocity, root gm by r1. This one T1. T2 will be 2 pi r by v, that is r2 by v2, that will be 2 pi r2 by root gm by r2. So if you consider, rearrange this one, 2 pi root over r1 power 3 by 2 by root gm, and this will be 2 pi r2 power 1 plus 1 by 2, that will be 3 by 2 divided by root gm. So if you need to find out T2 minus T1, just substitute G 6.67 to 10 power minus 11, mass is 6 into 10 power 24 of the earth, radius is 1600 kilometer, means 1600 plus 6400 kilometers, that will be 8000, 0064 plus 16, 8000 kilometers. For 600 kilometers, this will be 600 plus 6400, that will be 7000 kilometers. That means 7000 into 10 power 3 meters, 8000 into 10 power 3 meters is a radius, students, here. So what we can do here, so T2 will be, T2 minus T1 will be 2 pi root over gm is common in both the sides. T2 minus T1 if you write, so what will be the answer? Root over r2 power 3 by 2 minus r1 power 3 by 2. R2 is 8000 into 10 power 3, R1 is 7000 into 10 power 3. Just this is the final answer, students. If you substitute this radius 8000 and 7000 and G and M, G as 6.67 into 10 power minus 11, the M is 6 into 10 power 4 kg and 2 pi value 2 into 3.14, you will get the answers. And this is the final formula. You substitute these values and you will get the answer, students. Just calculation is lengthy, but this answer is as easy as it looks here. So the answer is 2887.156 seconds, students. You can use the calculation and direct final formula I got from two equations that I solved here, students. So next question. So this question is, you can consider it as a easy question, students. How? If pressure is constant in a thermodynamic process, then find the ratio of du is to dq is to dw. We know thermodynamics first law, dq is equal to du plus dw. But for isobaric process, students, pressure is constant. Pressure is constant. dq can be written as ncp dt, students. ncp dt. This you might have studied. For isobaric, it will be ncp dt. For different processes, nc dt will be the dq here, students. Depending upon the process, this will be the formula will change. C is the specific heat, molar specific heat at that for that particular process here, students. What is du? Du, whatever the process may be, we need to write as ncv dt. This, how ncv dt you need to write? This you will find in explanations. We keep detailed explanations on these questions. There you will be able to find out how is du ncv dt. In whichever the process may be, du should be ncv dt plus dw will be nr dt. dw is nothing but integral p dv. This I can explain because it's easy here. It is short here. Integral p dv. P is constant here. P comes here. Integral dv, that can be written as p into v2 minus v1. That is pv2 minus pv1. But we know by pv is equal to nRT formula, this will be nRT2 minus nRT1. So we can write it as nr dt. So if you write this equation, your problem is completed. For Cp, for du, dw, if you write the equation in this sort, your problem is completed. N gets cancelled, dt gets cancelled. So the answer is Cp is equal to Cv plus R. This formula you would have studied. On the basis of that formula only, this is there. For Cp is given 7 by 2 R, 7 by 2 R. Cv is given 5 by 2 R. He has given plus R here. So what is du, students here? Du is how much? Cv. Du is related to Cv here. So Cv is 5 by 2 R is to, what is dq here, students? Cp here. Cp is related to dq here, students. So what will be 7 by 2 R For work done, it will be how much students here? R. So what is the ratio of it one? So if you try to multiply with 2 in all the 3 fractions here, the answer will be 5 is to 7 is to 2 will be the answer, students. 5 is to 7 is to 2 will be the answer. That will be the first option. So these questions, some of the questions are very easy, just if you know the formula you will be able to solve. Some of the questions are formula based but lengthy calculations here. One or two questions will be tricky for you to understand. So this is the first 10 questions that I have taken analysis, and the remaining will be followed by Vijay sir, students. I hope you have enjoyed this analysis.
And hi students, and now we are going to start from the problem number 11. So in this problem he has given and two particles, two and charged particles with and various masses. So those two particles, what he has given is, one is the alpha particle and second one is the proton. These two particles are accelerated from rest under the potential difference of 200 volts. That is, these two charged particles are being and accelerated with a potential difference of 200 volts. That is, the same potential difference is being applied for both the charged particles having and various masses. So find the ratios of the de Broglie wavelengths. So when he is asking to find the ratios of their de Broglie wavelength, first thing you have to do is write the relation between the particle nature and wave nature, which is given by de Broglie, that is lambda is equal to h by p, where lambda is wavelength, p is the linear momentum. So obviously he is asking in terms of the potential difference, the value of wavelength. So you have to convert the linear momentum, because small h is obviously constant and you can't change it. So you have to change the linear momentum. So as you know, the linear momentum P is equal to root over 2m into kinetic energy. So you are applying the potential difference. So the work done here, as you know, that voltage or the potential difference is equal to work done by charge, and the work done is equal to Q into V, and obviously you can write the work done is equal to change in the kinetic energy. But to stop these electrons, you have to when they get stopped, their kinetic energy becomes zero, that is their final kinetic energy becomes zero. So which becomes is equal to half mv square, or you can write qv is equal to kinetic energy. So and substitute that into this equation, that is the kinetic energy is equal to q into v, so root over 2m qv. So now you got the relation between the wavelengths and also the applied and potential difference, masses and charges, because these two particles having various charges and various masses. So this is the relation what you have to consider now. So now let us see. So from that equation you get to know that, okay, lambda is inversely proportional to square root of mqv. Okay, but here the potential difference is same for both the particles. So as it remains constant lambda, you can simply write lambda is inversely proportional to square root of m into q. Okay, now do this, as he is asking the ratio of the proton wavelength to the alpha particle wavelength. So wavelength of proton by wavelength of alpha. So lambda is inversely proportional to both the mass and the charge. That is, it becomes is equal to mass of the alpha particle into charge of the alpha particle by mass of the proton into charge of the proton. So this is it. Now what is the mass of proton and what is the mass of the alpha particle? Obviously you know that alpha particle contains 2 protons and 2 neutrons, where you consider the mass of the proton to be approximately equal to the mass of neutron. Then you can consider it as the mass of the alpha particle to be 4 times of mass of a proton. So 4 times of mass of proton, okay, into charge of the alpha particle, it is 2 plus, so it is 2 times of charge of a proton, okay, by mass of proton, okay, m suffix p, and the charge of a proton, let it take it as q. So q and q get cancelled, mp get cancelled, so it is square root of 8 by 1. So square root of 8 by 1 is nothing but, so here we got the ratios of their wavelengths. The wavelength of proton by the wavelength of alpha particle as root over 8 by 1. So it is nothing but 2 root 2 by 1. So it is 2 root 2, that is option 2. Okay students. So this is the problem number 11. Next we will move to the next problem, number 12. He has given a tuning fork of frequency 504 Hertz. So first thing here what he has given in the problem, and write those things. So the first thing what he has given is the frequency, that is 504 Hertz, and a sound source of the resonance column tube experiment. So the tube is having a diameter of 6 centimeters. So let us write the diameter to be 6 centimeters. Okay. The 0 of the meter scale coincides with the top of the tube. What is the reading of the meter scale for the resonance to occur? So what is the condition exactly? So for to find the reading of the meter for resonance to occur is, as you know, it is a lambda by 4 is equal to L plus E. E is the correction. So you have to find these things. So he is asking what is the reading of meter scale, that is you should find the value of L. So first thing is you should have the value of lambda and E. Finding the value of E is very standard and it is very easy. So obviously E is equal to 0.3 times of the diameter, that is 6, that is 1.8. So you have the value of E. Next thing is you have to find the value of lambda, the wavelength. So what is the relation in between? He has given the speed also here. So here what is the relation in between speed, frequency and wavelength? And you know it is very famous rule, the speed is equal to frequency into wavelength. As you have to find the wavelength here, the wavelength lambda is equal to speed by frequency. So here the speed he has given is 336. By frequency what he has given, it as 504 Hertz. So this is the wavelength. And now and substitute the value of wavelength into this equation, where you will then make it into lambda by 4 is equal to L plus E. Then you will get the value of L, which is 14.86 centimeters. But he has given in terms of meters, you have to convert into centimeters. So you will get the option 1. So that is what we got here, 66.66 centimeters. And we have substituted in this lambda by 4 is equal to L plus E. So we don't have E, where E is equal to 0.3 times of the diameter, that we got it as 1.8. So finally we will get the value of L to be 14.86 centimeters, that is option 1. Next, in the problem number 13, he said the current I is flowing in a coil and at 2 points B1 and B2 are on the axis of the coil. So he is asking to take one coil, take one current carrying coil, obviously in the shape of circle. Okay. Then he is asking at 2 points the value of magnetic fields B1 and B2. So those 2 points are on the axis of the coil at a distance of 0.05 meter. So let us take this to be the axis of the coil. If this is the axis of the coil, he has said there are 2 points at a distance of 0.05 meters and 0.2 meters. Let those 2 points be here. First point is at the distance of 0.05 meters and the second point is at a distance of 0.2 meters. Okay. Next, if the ratio of magnetic fields at B1 and B2 are in the ratio 8:1. So he has given the thing that the ratio of magnetic fields at those 2 points is 8/1. 8:1. Okay, it is done. So what he has given, we have wrote here. So what is the formula for finding the magnetic field intensity at a point on the axial line of the current carrying coil? As you know this, as there is only one turn here, as there is only one coil, so you can write B is equal to mu naught IR square by 2 into R square plus X square whole power 3 by 2. So X is the distance from the center of the coil, where R is the radius of the coil. So here what you need to consider really is, suppose let us, he asked to find the magnetic field at the center of the coil. If you ask the magnetic field at the center of the coil, then the value of x becomes 0. If the value of x becomes 0, you can simply write mu naught I by 2r. But it is not the case here. So this is a special case where you can take in case of the electrons revolving in an orbit around a nucleus, where here the charge is moving because the rate of flow of charge is called the current. So you can take the orbit of the electron as a current carrying coil. So this case is very, very important. Okay. So now let us come to this problem again. So this is the formula what you have to consider. From this, obviously mu naught is constant, I is constant because the same current is flowing through the coil, and you have to find at 2 points of a single coil. So I is constant, obviously the radius is constant, 2 is constant. So from this, what you require x, but x is not present separately. So consider this combination r square plus x square whole power 3 by 2. So from this you can write B is inversely proportional to r square plus x square whole power 3 by 2. Okay. So he said B1 by B2 is equal to root over r square plus x2 square whole power 3 by 2 by r square plus x1 square whole power 3 by 2. He has given this ratio, which is obviously B1 by B2 is equal to 8:1. Okay. So this is given, or else if you want to make it make squaring on both sides, so then it becomes 64 by 1, or else bring that power 3 by 2 onto this side. That is like 64 by 1 is equal to r square plus x square whole power 3 by 2, and this is also like so as this is square, actually it is 1 by 2. So this is x2, this is obviously x1. So when it is like this, bring this power 3 by 2 onto this side. You can write 64 as 4 cube, or else you can convert into like 8 square. So then you will get the ratio of, as the value of r is constant, so these r's get cancelled out while you do the cross multiplication, and you will get the values of x1 and x2 at those both points. Or else if you can find the point of b1 and b2 separately, and you can find their ratios, or else you can do in this process where you get the values of x2 and x1. So where you will get it to be 0.1 meter. So this is what we have done exactly. So that is what we got it to be, 0.1 meter. So next, see the problem number 14, find values of L and C. So but he has given a switch also in between them. So if you see the switch, it is open, so there is no need to consider this. So this is like a series LRC circuit. So series LCR circuit, you have to find the values of inductance and capacitance in this series LCR circuit. So what you have to do to make that happen? So as this is open, no need to consider this. This is like a series LRC circuit. So first find the value of the voltage or the current passing through the resistor, because it will give the value of IRMS, that is the current root mean square value. So here the value of voltage, so V is equal to IRMS into the value of R. So V is 15 obviously, IRMS into the resistance he has given is 60. So IRMS is 15 by 60, that is 1 by 4 amperes. So you got the value of IRMS. Now let us come to the case of inductor, where they have given the angular frequency for this device is 100 radian per second. When you consider the inductor, okay, V is equal to the current IRMS into the resistance offered by the inductor, that is called the reactance of the inductor, because here the inductance offers the resistance by producing back EMF. Okay, it is not like the general resistance what it is offered by the resistance, where in case of the resistance the value of the resistance, because of its resistance the current gets converted into the heat energy. But in case of the inductance, it will produce back EMF. So because of that back EMF, it is offering the resistance to the given supply or the given value of current. So that is called the reactance of the inductor, that is XL. So here XL is, as you know, it is L into omega. So you have to find this value of inductance L. You have the value of IRMS, and he has given the voltage across the inductance, that is 20, and he has given the value of the omega, the angular frequency, that is 100. So you can write L is equal to V by IRMS into angular frequency omega. So V across the inductor is 20, and the IRMS what we got is 1 by 4 or 0.25, and the value of angular frequency omega is 100, that is 25. The inductance is 4 by 5 Henry. The inductance is 4 by 5 Henry. Next, and again you have to find the value of capacitance. So again, V is equal to IRMS into the reactance of capacitor XC. The reactance of capacitor XC is 1 by omega C. Okay, so in this you have to find the value of C. The voltage across the capacitor is 10, okay, and IRMS is 1 by 4, 1 by omega 1 by 100 into C. Okay, from this you can directly say that the value of C is equal to 1 by 4000. Okay, but he has given in terms of micros, so you have to convert this in terms of micro. So 1 by 4, you can write it like 1 by 4 into 10 cube, then 1 by 4 into 10 to the power of minus 3. It is 1 by 4 is 0.25 into 10 to the power of minus 3. Now you have to convert in terms of micro. So what happens, you have to shift 3 points, that it becomes 250 into 10 to the power of minus 6, that is 250 microfarad. So 250 microfarad, and inductance is 4 by 5, that is 0.8. So it is option 1 here. Okay, so that is what we have done in this problem. Next, in the problem number 15, if the ratio of intensities of two coherent light sources is 2x, find the values of I max minus I minimum by I max plus I minimum. So what is I max and what is I minimum? As you know, the value of intensity max is equal to square root of I1 plus I2 whole square. I minimum is square root of I1 minus I2 whole square. So he is asking the ratios of I max minus I minimum by I max plus I minimum. So that is root over I1 plus I2 whole square minus I minimum. So root over I1 minus I2 whole square by I max plus I minimum. Root over I1 plus I2 whole square plus root over I1 minus I2 whole square. This is the thing what you have to solve here, but he has given the ratios of the intensities I max by I minimum is 2x. So by simply solving these equations and by taking, and whether you can take here I1 as common or else I2 as common, and by solving this equation you will get the ratio to be 2 root of x by 2x plus 1. So that is what we have done here, okay, by simple solvation by cross multiplication. Next, in the 16th problem, he has given 3 particles, proton and deuteron and alpha particle, are having equal momentums and they are projected in the uniform magnetic field. So there is a uniform magnetic field such that their velocity and magnetic field are perpendicular. Yeah, this is the key term here. This is the key term you have to consider in this problem. He has given the velocity and magnetic field are perpendicular. So the force, these 3 are the charged particles, proton, deuteron and alpha particle. These 3 are the charged particles. These 3 particles are sent into the uniform magnetic field, that is into a magnetic field B. So obviously the force on a charged particle in the presence of magnetic field is q v cross b, where it is q v b sin theta, but here he said those are perpendicular. The velocity and magnetic field are perpendicular, that is angle is 90. So sin 90 is 1. You can write the force F to be simply q v b. Okay. So then the ratios of the magnetic forces, that is F1 is to F2 is to F3, and the ratios of speeds V1 is to V2 is to V3. First let us find about the forces. Okay, as you have the formula for finding the force on a charged particle in the presence of magnetic field, F is equal to q Vb, as angle is a 90. So first let us find for the particle 1, which is proton. But what are the clues he has given? Same momentum. Momentums P1 is equal to P2 is equal to P3. Obviously same magnetic field. B1 is equal to B2 is equal to B3. But here is there any other relation for linear momentum? Because to solve any equation there should be only one unknown. If you have two unknowns and you can't solve this equation. But here the charges are okay, but you don't have the velocities and you have uniform magnetic fields. With this, how can you find the values of force? Because he has given the linear momentum constant c. So c, for example, qvb into m by m, make it like this. Then it becomes q into mv, m into v into b by m. So here mv is linear momentum by m. Here linear momentum is constant, B applied magnetic field is constant, and charge by mass ratio if you find, then you can find the value of the ratios of force. So obviously here you can do like this, because the proton charge, let us take it as only q, the momentum is same p, and magnetic field is same, mass of a proton take it as m. So bpq by m is the force on the proton. Next, find on the second and third particles. If you consider the deuteron, again the charge, the value of charge q, and the linear momentum same, and the magnetic field is also same, and the mass is 2 times. Okay. Next, find the third one, alpha particle, where it says that the charge is 2 times, so 2q, the linear momentum same, magnetic field same, and 2 times of mass m, so it is 4m, because it contains 2 protons and 2 neutrons, where the mass of the neutron is approximately equal to mass of proton. So you can write 4 times of mass of proton like this. So what we get here, bpq by 2m, bpq by 2m, same as like this. So if you consider here F1 is equal to bpq by m, here F2 is equal to bpq by 2m, F3 is equal to bpq by 2, and if you take these ratios, it will come like 2 is to 1 is to 1. 2 is to 1 is to 1. Next is asking the ratios of speeds, the velocities. So velocity, if you have the linear momentum and mass, then obviously you can find the value of velocity. So because the linear momentum p is equal to mv, he's asking the ratios of speeds, so v is equal to p by m. Okay. First consider for proton, v1 is equal to, the linear momentum is same, the mass let it be m. Next for v2, the linear momentum is again same, but the mass changes, it becomes 2 times of m. For the alpha particle, the velocity, speed is equal to, here also the linear momentum same, the mass is 4 times of m. Here if you take this as the ratio, then it is 4 is to 2 is to 1. So that is option 1 here. Okay. So these are the ratios of forces and the velocities. Next, in the 17th problem, this is somewhat an easier problem. It is almost a theoretical question. The frequency of a wave to be modulated is 2 kilohertz and the carrier wave is 1 megahertz. So obviously, as you know, the carrier wave is of more frequency, is of very higher frequency, and this is the frequency of the wave that is to be transmitted. This is the frequency of the carrier wave. So he has given 2 statements here. First one is the assertion, where it gives the frequency range in which the signal operates is 4 kilohertz obviously. Then the sideband frequencies are 998 kilohertz and 1002 kilohertz. So here both the assertion and reasoning are right, and the assertion and the reason is the correct explanation of the here the statement upwards, that is the assertion. So it is the assertion is true and reason is true, and the reason is a correct explanation for assertion, that is option 1. Next, in the problem number 18, he has given the electric field in the direction of x and y axis. So he has given the field intensity to be E is equal to 3 by 5 times of E naught into I cap plus 4 by 5 into E naught times of J cap. So that is, there is the field in the direction of the positive x and y axis plane. Two planes P1 and P2, one in the xy plane of area 0.2 meter square, so and the other in the xz plane of area 0.3 meter square. So area A1 he has given it as 0.2 meter square, and the second surface area is 0.3 meter square are considered. Find the ratios of flux. So what is this? So as you know, the relation between the flux and the electric field intensity and the area, flux is equal to E dot A. So here he has given the area, so flux is equal to E into A simply. So phi 1, as he is asking the ratios, phi P1 by phi P2 is equal to E1 A1 by E2 A2. You have the value of E and you have the value of also both the values of the areas. If you substitute in this, then you will get the values of the ratios. So this is what we have done exactly. So phi P1 is equal to the EMF field in the direction of x axis 3 by 5 E naught into 0.2, what is given here. In the P2, that is 4 by, because it is in the direction of xy plane and this is in the direction of xz plane, so 0.3, which is area. So their ratios are 1 by 2. Next, in the 19th problem, two planets have same escape velocity but different masses. For same escape velocity, m1 r1 must be equal to m2 r2. We have to check whether these two statements are right or not. So first, right, to explain or to understand whether this is true or false, these two statements, here you have to consider the escape velocity, which is where the velocity is equal to root over 2 gm by r. Here, as you know, 2 is constant, capital G is the universal and gravitational constant, so it will also remain same. So here the escape velocity depends on the values of mass and the radius. So he said in the statement 1, the assertion two planets have same escape velocity, okay, but different masses. Is it possible? Yes, of course it is possible, because if it has different masses, also then it may have a different radius, then they both get and cancel each other such that these both velocities may be equal. Next, in the second reasoning, he had said that for same escape speed or for same escape velocity, m1 r1 must be equal to m2 r2. No, here the relation between the velocity, mass and the radius is v is proportional to square root of m by r. So it has to be the ratio of m1 by r1 must be equal to m2 by r2, not m1 into r2 is equal to m2 r2. So this reason is wrong. So it is option 3 where the assertion is true and reason is false. Next, we have the last problem, problem number 20. He has given a freely kept rod is heated and there will be no thermal stress. So here the keyword what you have to understand is it is freely kept rod. So when it is freely kept, even if you heat, of course there will be the change in the length and there will be change in the area of the cross section, but there won't be stress on it because it is free, because it is not attached to any of the ends. Next, when a rod is heated, then it expands. Of course it is also true, because this is the most common thing of what you experience. So both the assertion and reason are true, but this is not the correct explanation of the assertion. So here it is. So here it is option 2. Here it is not, actually it is given wrong here. So here it is option 2. So from the next problem, and sir will take after the class.
Okay, welcome back and good morning, all of you. And I hope you understood all the question which our colleague has done as of now. So we have solved up to question number 20 and the question number up to question number 20. The question were quite easy, and if you see, and if you're a regular follower of our YouTube channel, then you must have seen the kind of question that is appearing in JEE Mains are pretty the same, the kind of question that we're taking on in our sessions, regular sessions. Okay, so let's move on to next questions. So the next question is that if you see and if you have seen the nuclei chapter, in which where I was teaching you nuclei, how to solve a radioactive, what is half-life, full life, how to develop the relation, then in that case this is going to be very simple question. See, they are saying that we have two radio substance which is X and Y having N1 and N2 nuclei initially. Okay, so they have given the initial number of numbers. Okay, so what you have to remember that we have the given details. What is the given details? At t equal to 0 for X and for Y, I can say that N naught is equal to N1 and for this N naught equal to N2. Now what they're saying, the half life of X is, okay, so for half life of X is equal to, what they have given some relation is half of half life of B. It means whatever the half life of B is, this is the half of that value. Understand? This is the relation they have given. So from this relation I can also find out, if you remember the formula of half life, that is ln2 divided by lambda. What was the lambda? Lambda was your decay constant for 1 and for 2. So I can find out this relation, half of this over this equal to ln2 divided by lambda 2. So ln2 gone, half life of X over half life of Y. I can also have one relation that I am going to use later on, will be, this is X, for this is Y, this will be lambda 2 over lambda 1, and this lambda 2 or lambda this is Y into X is going to be 1 over 2. They have already given that for this 1 over 2 is going to be 1 over 2. So this is 1 over 2 equal to lambda of Y over lambda of X. This is also one relation we can get from here. Now next of the thing they are saying that after a time, so there is a one time which is t, for example, after a time of 3 half life. Okay, so in this case they have given the t as well, that t is the 3 times of half life of Y. These are the different relation they have given. They are saying the number of undecayed nuclei. Number of undecayed nuclei was, if you remember, the number of the relation was e to power minus lambda into t half, or basically you can say t, whatever the t you wanted to place it out here. Okay, this was the relation where n was your undecayed nuclei, where n was initial number of nuclei, and all the relation you can use and you can get your answer. Now they are saying that after 3 half lifetime, number of undecayed number of X and Y is equal. It means that this for X and the same for Y, the same way you can write for the Y, these two are equal. Understand? So if these two are equal, so I can say for that second boss that this is going to be nx is equal to ny. It means n naught into e to power of minus lambda x into 3 half life of y is equal to n naught e to power of minus lambda into y, and this is going to be 3 half life for y. Then n naught cancel out. You will able to find out the relation between here, because lambda x and lambda y we have already found the relation, which is something here, and the 3 half life also given, and after solving this problem you will able to find your answer. So only the question was to substitute in the question, the main part was to understand the question and place the value in correct order. So you can see that the relation we have already done, and these are the calculation which if you follow you will easily get that answer. The question was not so difficult. Now this is again very good question which comes, and for a newcomer this question can be quite confusing if you don't familiar with the ray diagram. Now the question is saying that when object is placed, there is one object is placed at 10 centimeter from convex lens, and when placed at 20 centimeter from convex lens, it produce image of same height. This is very good thing. Now the question can come when this is the case, when it is kind of possible. Now in this case they are not telling whether the image is inverted or it is basically the in the same kind of in the same phase. They have not telling, but they have only given one detail that both of them are having the same height. So is it possible to have the same height? So let's see from the ray diagram, which is this is a convex lens. So for example, in which case, so I don't feel there is any case in which you can see that object image will be of the same height, but there is one case you can relate, that is for virtual and for real image. For example, for a second, if I assume, let's suppose this is my focal length and this is my center of curvature. This is the second focal length and this is my second center of curvature. Okay. Now if you remember, if you place one object over here between C and F, you must have seen that you get your image somewhere here which is inverted and enlarged image, right? That which is inverted and enlarged image. For example, this is 1 centimeter. So there is a case that you may get 2 centimeter, 3 centimeter, whatever. Let's suppose 2.5 centimeter you are getting, right? This is the height. Now you have to look for that case in which you can get the same kind of height. So that case is only possible in the second case. And what is that case? That if you place object somewhere here, if you place your object between your pole and focus, in that case you will get your virtual image which will be somewhere here. For example, somewhere like from here, and you can get your answer for this. Understand? So for example, any ray which is going like this, it will become parallel like that, right? So there is one only case which exists. Sorry, this is not a case, this should not be here, sorry. For ray diagram, it should be in that direction. So for example, if you place your object over here, ray is coming, after that what will happen? It will pass through the focus, and if it is passing through the focus, you will get your back image. Second ray is going like this, so there is a possibility that you may get your virtual image here. And if you are making the virtual image over here, so in this case there is a possibility that you may get, let's suppose this is 2.5 centimeter, same kind of image you can get 2.5 centimeter again. Understand? So there are two different cases that in which you can get the same height. One can be your real image, other one can be your virtual image that we get, right? So in one case, if you see, your magnification is height of image over height of object. Now one case you can see this is coming downward, so this is going to have negative sign value, and this height of object will be positive. Why? Because it's projected toward, this is your xy plane. So this direction all the values are positive, here you have negative value. So since object is projected toward positive of y, so this your height of object will be positive. And if height of object is positive, you can see in this case magnification will be negative. Understand? In second case, if you see, in the second case, let's suppose that height of image over height of object. In second case, your height is projecting toward the positive direction, your object is also projecting toward the positive direction. So if you just divide these two values, the positive over positive you will get the positive as well. And in this case, the magnification will be same. Why? Because we are assuming the object will have same height as well as image will also have the same height. So magnification will be same but of opposite direction. Understand? So the logic was to understand up to here. Now if you remember, if you are able to understand, then I can say other formula I can use for the magnification was that magnification is also V over U for your this thing, for your lens. Now the lens formula is 1 over V minus 1 over U equal to 1 over F, right? This is the formula we have to use, right? So what I can say that I want to find out V over U. So what I'm just going to multiply. I can eliminate the V over from here. So I just going to multiply V over V minus V over U because I don't need V. So I am going to use only U. So I will multiply by U. Okay. So this is going to be this 1 over U equal to U over F. Because why am I eliminating the V? Try to understand. Because I have the U distance, I don't have the V distance. So I have to eliminate the V from the equation. So this is going to be nothing but 1 over M minus 1 equal to U over F. Now 1 over M can be written as U over F plus 1. So M can be written as, I guess, F plus U divided by F. So it's going to be F over F plus U. This is the relation which you have for magnification. Now since we know that magnification is the same, okay, but of opposite direction. So in one case I can say that M1 is equal to M2, but since this will be negative sign. So for one case I can say that F upon F plus U is always, we have to use this formula in with a negative sign. So since we already know that this is your convex mirror, if this is your convex lens, sorry, so object is somewhere here or it can be here. So in both the cases it is in negative direction, and if it is negative direction, so we have to take all the time, we have to take as negative. This is U1, and in second case this is going to be F over F plus U2 or minus of U2. You place the value, we have two object distance, that is 10 centimeter, and in other case we have 20 centimeter. So if I place that value, so F over F minus 10 equal to minus F over F minus 20. F and F cancel out, we are going to left with minus 1. So F minus 20 is going to be negative F plus 10. This is going to be get positive, so F plus F will become this value. It goes here, it become 30. So I guess 2F is 30 centimeter. So F will be 15 centimeter. This is the process which you have to follow to get your focal length. Question was pretty easy. Now, in a thermodynamic process, there is thermodynamic process happening. Pressure and volume, there is one relation they have given, that pressure and volume is something related like this. Now they are saying that if initial temperature is this one, so what is the given detail we have? So given detail is they already given that P equal to K into V cube. Okay, T1 they have given, T1 is your 100 degrees Celsius, T2 they have given that is 300 degrees Celsius. Now if the work done they have given is equal to X into NR, so work done is given X times N into R. This is the relation which they have given. Now they are asking find the value of X in this case, where N is the number of mole. We have to find out the relation. So what we need to remember, that work done is what? So if you remember, you can see the pressure is getting varied with your volume, and whenever there is a function, some kind of relation function, we have to use the integration or differentiation process. Simple thing. So let's suppose the work done, we know that work done is from V1 to V2 P into dV. Since the pressure is a function of volume, so we have to replace this thing and we have to keep the pressure in terms of volume. So what I can say that V1 to V2 is going to be K times V cube into dV. One more thing, try to understand what does it mean. It also means that P1 it can be written as K times V1 cube, or P2 can be written as K times V2 cube. This is also the meaning of that. So when I place this thing, I am going to have K times V power 4 divided by 4 from V1 to V2, and I can place this value. So K by 4 into V2 power 4 minus V2 power 4 divided no divided. Now if you multiply K inside, you just relieve it. So just now I told you that K into V1 is P1. So in the place of here, since we have 4 power, I can write P2 into V2 minus P1 into V1 divided by 4, and we already know that PV is equal to nRT. It means P1 V1 equal to nRT1. Same way I can place this value in place of PV, I can place nR into T1 or nR into T2. So I am just going to place nR over 4 T2 minus T1. T2 I already know, T2 is 300 and this value. So I am going to get the work done to be nR by 4, and this is how much, 300 minus this. So this is going to be 200. So you just cancel out, you are going to get 50 times nR will be your work done, and they have given that work done has to be related to equal to X times nR. nR cancel, X has to be 50. That has to be your answer. This is the process you have to follow to get your answer. So for solution for this has to be, the correct answer is 50. Okay, second question they have given, simple question. I don't find I need to tell you this definition because this time question we have solved so many times. Now they are saying there is a non-conducting container. Not conducting container means, what does it meaning? That conducting and non-conducting, try to understand. Conducting means let's suppose this is my iron block. Okay, this is iron block. Inside the iron block we have the atoms. So if they have energy, they will able to conduct with atmosphere. What does it mean? That some part of energy will be coming out from the if you place something in container, then some part of heat will be coming out. For example, in your daily life, let's suppose you're drinking the coffee in your, let's suppose, steel cup. So what will happen if you touch that, some part of the heel is able to come out. That means it's conducting. And let's suppose if there is a plastic kind of thing, or if you use thermocol like that, so what will happen, your heat will not able to come out from that glass. That is called the non-conducting, that your glass is not conducting with atmosphere. That is the meaning of conducting and non-conducting, which you have to remember. So over here they are saying that there is a one non-conducting moving block. So non-conducting means whatever the energy is inside, the same has to be out, same, it will not change with atmosphere. Now question is that it's moving with 30 meter per second. So this is a block 30 meter per second. Now since this is moving with 30 meter per second, right, and contains 1 mole of monoatomic gas. Monoatomic gas, what is the degree of freedom for monoatomic gas? That is 3. What is the degree of freedom? Degree of freedom is that, let's suppose if you leave the object, in how many direction it can move. So it can move in your x direction, it can move in 3 direction, x and y and z. So it has a degree of freedom equal to 3. Now what is the kinetic energy of one particle? I am talking about one particle. So one particle, the kinetic energy for internal energy, if you remember, that is F by 2 RT. This is for one particle. And if you are talking about the kinetic energy for number of mole, it is going to be F by 2 nRT. This is the relation which you have to remember. And what is F? F is the degree of freedom. N is what? Number of moles. This is what relation you have to find. Now what happens? This block is moving with 30 meter per second. It means inside the block, if I have one particle, then that particle is also moving with 30 meter per second. If I have 1000 of the particle, they are also moving with that velocity, right? So there will be one velocity because of the block, and there will be another velocity because of inside the particle which are moving. Understand? So that is the relation. Now after some time, what happens, that inside it, and the mass of the mole, whatever the gas they have filled, okay, that is 4. So basically for you is basically they are talking about, I guess, about whatever the gas may be. Okay, if container suddenly stop, then its temperature changes delta T. Okay, and what is that change the temperature delta T? This is the value. Wait, 1 mole of the gas inside it. The mass of the gas inside the container is this much. If the container suddenly stops, then its temperature changes delta T. Okay, change in temperature. Okay, now they have given some relation. What is, so this should be the change in kinetic energy actually. Okay, they have given, they have not mentioned the properly, but this has to be the kinetic energy. What should be the change in kinetic energy? Okay, so what will be the value of x? So they are saying that when, let's suppose, one object was moving, all of a sudden it came to stop. So if the temperature changes delta T, so what will be the change in kinetic energy? And they have equated equal to x over nr. So this problem is super easy. Just calculate the kinetic energy of the block, calculate the initial kinetic energy of the block when all the particles were moving, final kinetic energy when it is about to stop, and just subtract that, you will get your answer. So I'm just not going to use so much time because we have already solved this. These questions comes are direct question and just memory based questions. Okay, so if you use this relation, you will get that. Okay, second and very good question, and good thing is that from AC circuit, if you remember that power factors and all these questions are not coming, but there most of the questions are asking in resonance in every shift. So now what is the question they are saying? There is a transmitter circuit, whatever may be, it is transmitting EM wave, and the wavelength they have given is this much. If the capacitor, so what is the given details we have, boss? So given detail is lambda is equal to 960 meters. Okay, then they have given capacitor. Capacitor is 2.56 microfarad, mean 10 to power minus 6 farad. Self inductance is L, which is given to be P into this value. Okay, I'm sure they are asking for this value. This is H Henry. All right, then the value of this. And one more thing is happening, that they are saying that when you connect those C and L across the circuit, resonance is happening. And resonance happens means the power becomes maximum, current become maximum. And what is the condition to have the power resonance circuit? So if you remember the current to have the maximum, the formula is V over R square plus XL square, XL minus XC whole square. To have the maximum current, to have the maximum power, in that case your current has to be the maximum. Okay, and it is only possible in one case when this value becomes 0. So if the this part is decreasing, this part has to be, it will become maximum. So this is only possible when your XL become XC. XL is omega times L and X is 1 over omega C. You just compare this value, you have L, you have omega. Omega is also given, no, not given. So omega you can find. How to find out the omega? Omega is what? It is 2 pi f. What is f? F is frequency. Frequency is what? C over lambda. C is the speed of light, lambda is the wavelength they have given. If you place the value, only one variable will be left, that is C, and you will able to find that. So again, we are not going to waste the time to just calculation. We are hoping that you will able to do that. Most important thing is the understanding of the concept that we are focusing right now. Okay, very good question. Very good question. Now see what happens. There are 512 mercury drops are there. Okay. Now initially each has a potential this much volt. All right. Now all the drops are combined to make a single drop. Then what will be the potential of the single drop? Very good question. It is the same kind of question in a mathematics you must have done. Let's suppose I have 10 chocolates, spherical chocolates, and if you combine, if you just break and if you make big chocolate, how much will be the radius of that chocolate, right? So that is in the same concept, this is also related. So how to solve this thing? So see, simple thing boss, simple we have to follow. So I can say that let's suppose whatever maybe there is one chocolate or when there is a one drop is having radius r, and if you combine all these 512 or whatever, so there will be one big chocolate which can have radius to be capital R. So these are the relation possible. So now what we know that whatever the space is taken by 512 drops, that will be equal to the one big drop. So what I can say that the volume taken by the big one or this R1 will be equal to 512 times the volume taken by the small r volumes or small drops, right? So for that I can say 4 by 3 pi r cube should be equal to 512 4 by 3 pi small r cube. Now this value gone, r cubes come out to be 512 into r cube, and from here if you able to relation find out what is the cube root of 512. Cube root of 512 is 8. 8 into 8 is 64. 64 into 8 is 512, right? So from here you will able to derive one relation that r is going to be 8 times of small r. This is the value of capital R. Now since we know what is the volume, what is the voltage, okay, what is the potential because of one drop, that is k cube by r, small r. This is one relation we know. Now let's suppose new potential because of the 512 charges will be k into 512 q divided by capital R. If you just divide this value, because they have given that is for 2, and if you just divide, this is going to be divided by 2 equal to k, and k cancel, and so 512 q divided by q, and is going to be this value. If you divide this value, this will come down, so this capital R over small r. Okay, so this q and q cancel out. V dash is going to be twice of 512 into r over capital R. Capital R is 8 times of small r. So r and r is cancelled, 8 and 2 is 4, and 4 you cancel, this is going to be 128. This is the value of V dash. This is what you have to remember. Okay, simple question. Again, all these things you just refer the solution, you get your answer. Very good question. This question is basically oral based, so I don't want to use the pen, and I don't want to use I don't want you guys to use that as well. Why? Because if you see the problem, very easy. See what they're saying, that figure show different ABC. There is octagon. AO is given, the vector for AO is given, like the vector is projected toward AO. What is the meaning of AO, boss? AO, when they say AO, it means the final vector minus initial vector, that is going to be this one. Now they're saying there has some value, whatever the value may be. Then find the value of this. Now what are these different vector we have? AB vector plus this vector plus this vector plus this, so much this. Okay. Now try to see, this is x times of AO. So whatever the value of AO is, if you add all the vector, you are going to get this thing. Now try to derive one relation, very important. Let's suppose A to B. This is my A to B one vector. Then second vector is A to C. A to C will be this vector. Then A to D is this vector. A to E is this vector, A to F is this vector, A to G is this vector, this thing. Now let me connect them in one order, proper order. Okay. So if you try to add all the vector, okay, because the question is all about adding all the vector. So I'm just going to add all the vector and now try to see what will happen. This is A to B. If I connect A to C from here, I'm going to have like this. Then A to D, maybe something like this. Then A to E, something like this. So finally, if you keep connecting all the time, what will happen? You are going to get one polygon, and all the sum of, if you are able to form the polygon, if you start from 0 and again if you are able to stop at that point, it means the vector of addition will be 0. Understand? That is the logic, and based on that you can get your answer. Alright, so we are not going to use so much time. Okay, in the given circuit, find the energy of J stored at 4 seconds. Okay, again the simple question, formula based, integration based. They are saying that find out the time energy stored at t equal to 4 seconds. At t equal to 0, circuit is closed. Okay, so as soon as they are closing the circuit, what will happen? There will be the inductor, it will start storing the energy. Understand? It will start storing the energy. But in this case, they have given the voltage to be the variation of time. It means when the time is increasing, voltage is also increasing. So how can we solve this thing? This is very simple problem, right? So if you remember, boss, what is the voltage across that? Okay, they have already given this thing. So voltage is that minus L into di over dt. This is the relation we know for voltage. In this case, which function is a variable? Voltage is variable. So I am going to place 3t equal to negative L into di over dt. dt will multiplied over here, 3 times t into dt will be negative L into di. Now simple thing, just integrate that value. Why? Because in this case the time is variable, in this case I is variable. So time is from 0 to how many seconds? They are talking about 4 seconds. I don't know how much, no, sorry. Time should be in this direction. Time should be in this L into di. Okay, time is here, so limit should be 4 times for here. The current should be from 0 to I, whatever the current may be stored. And then if you integrate, this is going to be 3t square by 2 is going to be L into I. This is the value of you will get from here. From you use this value and you place in that formula where you will able to store the energy, and that is how you will able to solve your numerical. Now simple question, I want to show you the solution directly. Question has nothing to do with that. You have the battery and they are saying that once you close K2, the current will K1, and if you keep open, the current will be going from here. So potentiometer, that is E1 is directly proportional to L1, E2 is directly proportional to L2, and if you are able to solve, if you find the ratio, you will get your solution. So this is the total classes for physics. Okay, these are different questions that we have discussed today, and I hope you enjoyed the lecture. You can come back and you can join our you can download the app, you can solve as many as question you want, try to improve your ranks. And the good thing is that again we are saying that whatever the question that we are getting in this JEE Mains and questions, that we have already uploaded in our Skyget app. So just download that app. In that app you will able to solve so many questions. Those questions will be very useful for you. So thank you very much, have a good day, and I wish all the best for the students who are going to appear for your next in upcoming a few days, or maybe in, let's suppose, in next year. So for all of them, the questions are going to be very easy. If you are very good with conceptuals, you are going to rock.